Now we will perform the cross validation. For cross validation, we will call cross underscore validation, which we already imported. And now we will write cross underscore validation dot cross underscore val underscore score. That is the method. Inside that you will fill the method name, model name, which is model logistic, which we have already defined. Then give x and y, and then give number of partitions of the data you want. So you have 5-fold. Basically what this will do, I have already told, but I am just giving again a certain glimpse of that, what is going to happen. So we have x and y. It will create 5 parts of it, and it will basically train on 4 parts and then test on the 5th part. It will do number of times like this, train on 4, any 4, and then test on 5. So it gets the understanding of what is the error in the unknown data set without actually performing a prediction on the test data set. It is actually partitioning the actual data training data set into 5 parts and then testing it internally. So training only on 4, not training on the 5th part, because it will if it train on the 5th part and it is testing also on the same testing data set on the same data set, then the definitely accuracy will increase. But we will only train on some data set and then we will test on the unknown data set. So that's why the cross validation is a very important thing. Now if you just run this, sorry, this is this. Now if you run this, now you have run the cross validation. Now this was the model logistic, how it looks like. It gives all the parameters inside, cost function, cost and the class weight, dual, fit intercept, whether you want to fit the intercept or not, and all these. You can change these parameters inside. You can give it here. If you want to give C, you can give C 0.2, anything what you want. I'm not doing that right now. And then if you want to see what is the cross validation values, because we have 5 times we have done the cross validation, so 5 times we get the testing dataset estimate accuracy. That's 79%, 81%, 76%, 76.4, 81.3. These are 5-fold cross validation happened, and we get the 5 estimates of the testing dataset error. These are just the estimates. We have not actually performed the predictions on the actual testing dataset, but we have just estimated the testing dataset accuracy by just performing the cross validation. Now if you want to see these predictions on the plot, you can just write it like this. So these values, these are plotted, 79, 81, these are plotted in the plot. And if you want to see the mean value of it, just write model logistics cv.mean. So mean value of the testing data set accuracy estimate is, this is estimate, 78.9. So if you now perform the prediction on the testing data set, it should be around this. Not sure, but definitely based on the cross validation, it is saying like you will get an estimate of this much. So in the next video, we will perform on the testing data set.